Hello Year 11 and welcome to our fourth video here on Calculus. Today we're looking at the chain rule. Okay, the chain rule allows us to differentiate some more complex functions than we've dealt with up until now. Now the phrase that's often used here is the function of a function. Right? Again, examples are going to make this clearer probably, but if my function could be expressed as the function of some other function, right, we can use the chain rule, and we start by using a substitution. Right? If the function of a function, we substitute our inner function. Right? So we say let u equal that function, which means that y equals the function of u. Then I differentiate y with respect to u. Right? Not with respect to x, but with respect to u. So it's dy on du this time. Then we also differentiate the substitution. Okay, so our substitution is a function of x. So we differentiate u with respect to x, right, to get g prime x. And then we multiply those together, right? Du on dx times dy on du. It's sort of as though, it's not exactly as though, but it's a bit like the du's cancel out, and I'm left with dy on dx. Okay. Now, all of that so far seems like so much gibberish, and I suppose maybe coming from me it might be. But with an example, I think it comes together reasonably well. I like my hair today. So, here's my function. You see, this is a function of a function. I've got a function inside here, x squared minus 1. And after I've done that, I apply some other function to it. I raise it to the power of 4. So my substitution is going to be x squared minus 1. I say let u equal x squared minus 1. Which means that y equals u to the power of 4. Now I differentiate y with respect to u. Right? That means the 4 comes down and reduces down to a 3. So dy on du equals 4 u cubed. Now that I've differentiated that, I'm going to get rid of the u by substituting, right, sort of reversing our substitution, put the x squared minus 1 back in there. So it's 4, outside of x squared minus 1, to the power of 3. Now that's not the derivative of the function. That's only the derivative, well, it's the derivative of the function with respect to x squared minus 1, but I need to differentiate it with respect to x. So, next thing I do is differentiate our substitution. So I'm going to differentiate u with respect to x. Right, so du and dx, when I differentiate this, I just get 2x. Then I multiply these two things together. Dy on du on dx. It's as though the du's cancel. I'm left with dy on dx. So it's 2x times 4 outside of x squared minus 1 to the power of 3, which is 8x outside of x squared minus 1 to the power of 3. There you go, that's the chain rule. Choose a substitution, right? Recognize it's a function of a function. Choose a substitution. Differentiate the function with respect to the substitution. Differentiate the substitution with respect to x. Multiply those two derivatives together, and that's the derivative of the function. Righto. So, let's go over that again. Differentiate a function of a function. We use a substitution. Differentiate the function with respect to the substitution. Differentiate the substitution with respect to x. Multiply those together. That's all. Righto. Hope that made sense. If not, you know, give me a hard time in class. Certainly jot down some questions and ask me, and we'll work through those together. Other than that, our next exercise is on differentiating with negative indices, something to look forward to. A couple of short videos coming up, very short, I think. Anyway, see you then.